Welcome back, students. So in the previous class, we learnt about the acidic strength of alcohols, right? We saw how primary alcohol is greater in comparison with secondary and tertiary alcohol. Then we also saw that water is highly acidic when compared to all the alcohols, right? So that is what we learned in the previous class. So today what we'll be learning is chemical reaction, further chemical reaction, that is okay. So today the chemical reaction which we'll be learning is esterification. Okay. Now what do you mean by ester? So when is ester formed? Usually ester means whenever acid or any of its derivative combines with alcohol. Okay. Whenever acid or any of its derivative combines with alcohol, what do we get? We get something known as ester. This we have already learned. Ether, ester, we have already learned this. So what is it? Whenever acid or its derivatives combines with alcohol, what do we get? Ester. Now if I have to write general reaction for that, it would be something like this. First is acid. How do we write? R, C double bond O, O, H plus alcohol, H, O, R, right? So this is how we write. Alcohol I have written in the reversible manner, but it means the same. So now what happens here, whenever I combine this with alcohol, what do we get? Ester. Now how do we get that? Here we see that in the alcohol what happens is, let me just write, this is alcohol, okay, and this is acid. So whenever alcohol, what happens in the alcohol is OH bond cleavage takes place. Okay, in my alcoholic group what has happened? OH bond cleavage takes place, and acid group, OH group is removed. Okay, in the acid group OH group comes out, such that forming the other part as R, C double bond O, O, R dash plus water molecule. Now I told you, usually people will think since acid, I'm taking acid, usually acid is the species which has to donate proton. But in this case, it is not like that. Here, acid group, what is being removed? OH, hydroxyl group is removed, okay, OH minus. And here, what is removed? H plus is removed. Now, how do we know that H is removed from alcohol only and acid OH is removed? It is experimentally proved. Here, what happens is the oxygen which I'm using, right, okay, the oxygen which is being used, star mark hakidannalla, that oxygen is actually an isotope of oxygen. This is an isotopic form of oxygen, O18, okay, na? So then this is usually radioactive in nature, okay. This oxygen O18 what I'm using is radioactive in nature. Experimentally we see that whenever this acid combines with alcohol, OH bond cleave agirutte, we see that OR group is together, RO group ಏನಿರುತ್ತೋ ಒಟ್ಟಿಗೆ ಇರುತ್ತೆ, H group remove ಆಗಿರುತ್ತೆ. That is the reason we say that hydrogen is cleaved from this group and then OH is cleaved, forming ester. Okay, ester. And then what is this? This is water. Okay, and one more thing, students, this is reversible reaction. I forgot to mention, this is a reversible reaction, and this reaction, it is taking place in the presence of acid. Okay, this reaction is a reversible reaction and taking place in the presence of what? Acid. And one more thing is, since it is a reversible reaction, obviously you know that reversible andrenu matte product ಆಗಿದ್ದು reactant ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಬಹುದಲ್ವಾ. So what you have to do, ಇಲ್ಲಿ ವಾಟರ್ ಏನಿದೆಯೋ ಮತ್ತೆ ನಾವು ಅದನ್ನ ಬಿಟ್ರೆ ನಮಗೆ ಪ್ರಾಡಕ್ಟ್ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಬರೋದಿಲ್ಲ, ವಾಟರ್ನ ಹಾಗೆ ಬಿಟ್ಬಿಟ್ರೆ, because it is a reversible reaction. So what I have to do, I have to remove water. Water molecule has to be removed. Okay, water molecule has to be removed so that the reaction takes place properly. ಇದು ಯಾವ ಬೇಸಿಸ್ ಮೇಲೆ ಹೇಳ್ತಿದೀವಿ? ಲೀ ಕ್ಯಾಟಲಿಯೋಸ್ ಪ್ರಿನ್ಸಿಪಲ್. Obviously we have learned that. Based on that, here what happens? Water molecule remove ಆಗಬೇಕು so that again the reaction can takes place. Okay, now this I explained. Now moving on. Okay, so suppose this was regarding our acid and ester. Generally ಯಾವ ತರ ಬರೀತೀವಿ ಅಂತ ಹೇಳಿದೆ. Now suppose I have its derivative. Let me just take something like this. Okay, now this is combining with alcohol. Okay, so here in the middle I'll be writing this reaction because of the inconvenience of the space. So ಈಗ ಇಲ್ಲೇನಾಗುತ್ತೆ ಈ reaction, what is this known as? This is known as acid anhydride. Okay, derivative acid anhydride. It is combining with alcohol. So here this is the isotope. It is this is a reversible reaction which is taking place in the presence of acid. Now what happens? Again Here alcoholic group ಅಲ್ಲಿ ಯಾವುದು ಕ್ಲೀವ್ ಆಗುತ್ತೆ, ಹೈಡ್ರೋಜನ್ ಆಕ್ಸಿಜನ್ OH ಬಾಂಡ್ ಕ್ಲೀವೇಜ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಲಾಸ್ಟ್ ಟೈಮ್ ವಿ ಸಾ ದಟ್ ವೆನ್ ಇಟ್ ವಾಸ್ ಲೈಕ್ ದಿಸ್ ಆಸಿಡ್ RCOO OH, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಬಾಂಡ್ ಹೋಗುತ್ತೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ RCO ಗ್ರೂಪ್ ಉಳಿಯುತ್ತೆ, ರೈಟ್. ಸೊ ಹಿಯರ್ RC ಡಬಲ್ ಬಾಂಡ್ ಗ್ರೂಪ್ ಉಳಿದಿದೆಲ್ಲ ತೆಗಿರಿ. ಸೊ ವಾಟ್ ಡು ವಿ ಗೆಟ್? ಸೊ ವಾಟ್ ಇಸ್ ದ ಪ್ರಾಡಕ್ಟ್? ಒನ್ ಇಸ್ ಇದು ಇದ್ರ ಜೊತೆ ಕಂಬೈನ್ ಆದ್ರೆ ದಟ್ ಇಸ್ CH3 C double bond OR. So first product is ester. Okay, ester ಆಯ್ತು. ಇನ್ನೊಂದು ಏನು, CH3 C double bond OH, acetic acid. Okay, what is the other product formed? Acetic acid. Okay, so now here what did we get in this reversible reaction? We got one is ester and one more is acetic acid. So ester ನಮ್ಮ main product ಆಗಿರೋದ್ರಿಂದ ನಾವೇನ್ ಮಾಡಬೇಕು, here also acetic acid has to be removed based on Lee Catanese principle, so that we get more and more of product. So this is with reference to acetic anhydride ಯಾವ ತರ ಆಗುತ್ತೆ ಅಂತ ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದೆ. Okay, now moving on for the third example. Now where do I go? Now moving on for the third example.